Imagine, just for a second, waking up tomorrow morning, pouring your coffee, and logging into your personal bank account. And you immediately notice your investment portfolio is up 5%.
Which is a nice way to start the day.
Right, a very nice way. But here's the thing. You didn't hire a new broker. You didn't approve any trades. While you were sound asleep, your portfolio actively rewrote its own trading algorithm.
It rebuilt itself.
Exactly. It analyzed 1 million new data points, executed, 10,000 micro trades, and just made you richer. Or think about logging into your business dashboard, right? Only to find out that your internal software completely redesigned its own user interface at 3 a.m.
Just completely on its own.
Yeah, because it realized the old layout was slowing your team down by 12 seconds per task. You didn't lift a single finger. The system simply woke up, looked at itself, and decided to be better.
I mean, it sounds entirely like science fiction, right? Like something out of a movie. But what is truly staggering here is that we are no longer talking about the distant future. Like, we are talking about the present moment. We are watching the birth of true agentic loops.
Okay, agentic loops.
Yeah. To put it in perspective for you, for the last few years, we've basically been living in the era of the passive chatbot. You type a prompt, it gives you an answer, and then it goes back to sleep.
Right, it's a tool. It just waits for you.
Exactly. It's a tool. But what we are witnessing right now is this shift from a passive tool to an active autonomous engine. An engine that runs the scientific method on a continuous, never-ending loop.
Okay, let's unpack this, because for anyone listening, whether you are running a business, writing code, or you are just, insanely curious about where the world is heading, this is the tectonic shift you need to understand.
It's massive.
It really is. So our mission for this deep dive is to explore the explosive emergence of something called auto research, which is a concept recently launched by Andrej Karpathy.
He's widely considered one of the godfathers of modern AI, so when he does something, people pay attention.
Exactly. And right now, this concept is going completely viral across the tech landscape. We are pulling our insights today from a highly detailed breakdown by entrepreneur Greg Eisenberg.
It's a great source, really gets into the weeds.
Yeah, he breaks it down perfectly. We're going to figure out exactly what this technology is, how it works under the hood, and we're going to explore how this relentless looping intelligence is preparing to completely rewrite everything.
Everything from local marketing agencies to global finance, right down to the way we discover medical cures.
So to really grasp the magnitude of this, we can't just talk about the theory, right? We have to understand the mechanics.
Yeah, we need to look at what Eisenberg so perfectly describes as a super nerd robot intern.
A super nerd robot intern. I love that phrasing.
It's brilliant because
Okay.
once you understand the mechanism of how this intern works, the massive downstream effects on society, they just become incredibly obvious.
Okay, so let's define what this super nerd robot intern or auto research actually is on a functional level. We are talking about an AI agent that is specifically designed to run short, continuous training experiments on other AI models or on software code.
And when we say short, the time frame is critical here.
Right.
We are talking about experiments that take roughly 5 minutes each.
Wait, 5 minutes? Just 5?
5 minutes. That parameter alone changes everything. I mean, think about human research. A human developer or a scientist might spend weeks or months or even years agonizing over a single hypothesis.
Oh, yeah. They have to research, build a prototype, test it, write a whole report.
Exactly. And this agent compresses that entire cycle into 300 seconds.
Okay, so let's walk through what actually happens in those 300 seconds. You start by giving this agent a single crystal clear goal. Eisenberg uses the example, make this small AI model smarter.
Or it could be, make this Python script run 10% faster.
Right. And once you hit enter, you just step away. The agent takes over completely. In minute 1, it plans out different settings and code changes based on your goal.
It's making a hypothesis.
Yeah. And then in minute 2, it literally opens the Python file and edits the code itself. Minute 3, it runs a training experiment or test simulation on a server.
Just executing the test.
Minute 4, it reads the resulting metrics. And then in minute 5, it asks itself one ruthless binary question.
Is the result better?
Exactly. Is it better?
And that single question, is it better? That is the fulcrum of the entire paradigm.
Yeah.
Because if the answer is no, like if the new code is slower or the model is dumber, the system simply logs the attempt.
It basically just says, oops, that didn't work.
Yeah, it effectively writes down, okay, changing variable x to 42 was a disaster. and then it discards that configuration entirely.
It just deletes it.
It reverts to the baseline. But if the answer is yes, if there's even a fractional improvement, like a tiny percentage point, it saves those changes.
And that new configuration becomes the new baseline.
Precisely. And then it instantly starts a new 5-minute timer to try and beat that new baseline.
It really reminds me of that old fairy tale, you know, the shoemaker and the elves?
Oh, yeah.
Where the shoemaker leaves the raw, uncut leather out on the workbench at night, goes to sleep, and by morning, the elves have perfectly crafted these beautiful, optimized shoes. It feels like pure magic.
It's a really fun story, but it's actually a slightly dangerous way to think about it.
Wait, really? How so?
Because the elves in the story possess inherent human intuition.
Oh, I see what you mean.
Right. They know what a shoe is supposed to look like. They know it needs to fit a human foot. They understand comfort and aesthetics and all of that.
And these AI agents possess absolutely none of that.
Zero.
Yeah.
They have no concept of a shoe or success or business value. They only know the strict mathematical metric you force them to chase.
Wow.
So it is less like magic elves and much more like a blind, relentless bulldozer.
A blind bulldozer. I love that.
Yeah.
Because that implies if you point it in the wrong direction, it's just going to efficiently destroy everything in its path.
Exactly. It'll just optimize the wrong thing perfectly. And this touches on the exact boundary line between the human and the machine moving forward. The AI does not possess intuition.
Right.
If we connect this to the bigger picture, we are seeing a massive shift from generative AI to iterative AI.
Generative AI being what we're used to right now.
Yeah, like ChatGPT. You give it a prompt, and it generates an image or an essay.
Yeah.
But iterative AI refines something toward a highly specific target.
Okay, iterative.
But it relies entirely on the clarity and the mathematical precision of the task you assign it. You cannot just tell an auto research agent to make my business better.
Because it doesn't know what better means for your specific business.
Right. You have to translate your human intuition, like your desire for a more profitable business, into a hard, measurable metric. You have to define exactly what better means in terms of dollar amounts or conversion rates or processing speed.
You have to build the ruler that it uses to measure itself.
You have to build the ruler. The human becomes the goal setter.
The architect of the success metric. We just hold the compass and the AI becomes the tireless engine moving us north.
Precisely. And what makes it so incredibly effective as an engine is something human beings inherently struggle with. I really want to highlight the profound significance of that discard function we mentioned a moment ago.
Oh, right. When it throws away the bad code.
Yeah. Think about how human beings work. When a human developer spends 2 weeks writing a complex piece of code, or a marketing team spends a month designing a new campaign strategy.
They get emotionally attached to it.
Yes. It becomes their baby. Yeah. The initial data shows it isn't working. What does the human do?
Oh, we rationalize it. We say, oh, the market just needs time to understand it. Or let's just tweak the colors on the button.
Exactly. We fall victim to the sunk cost fallacy. We hold on to bad ideas because we spend so much time on them.
Human ego is the ultimate bottleneck to pure optimization.
It really is.
Okay.
But this auto research system is completely devoid of ego. It is ruthless.
Yeah.
It discards failed configurations without a second of hesitation or emotional attachment.
Just doesn't care.
It logs the failure, maps the boundary of what doesn't work, and moves on instantly. It is the scientific method executed with a kind of cold, beautiful purity.
And what's wild is how accessible the architecture of this system seems to be, at least conceptually. Toby Lutke, the CEO of Shopify, was actually discussing this recently.
Oh, interesting.
Yeah. Now, he's obviously a highly technical founder, but even he noted how surprisingly simple the setup is. He explained that you literally just create a folder on your computer called Auto.
Just a standard folder.
Just a folder. Inside that, you drop a single markdown file named prompt.md, which is just a basic text file containing your human instruction.
Oh, yeah.
Then you include a benchmark script, which is the ruler we just talked about, so the AI knows how to measure success. You make a branch of your code, and then in his words, you just let it rip.
Let it rip.
Yeah.
It's an incredibly casual phrase for unleashing a continuous engine of self-improvement. But that simplicity on the front end, the basic folder, the markdown file, it masks a massive, towering requirement on the back end.
Yes, and this is where reality hits you right in the face, because before you can just let it rip, you need the right engine to actually power all that relentless 5-minute iteration.
You can't just run this on anything.
No. And as it turns out, the typical laptop sitting on your desk right now, the one you might be listening to this deep dive on, is just not going to cut it. Which brings us to a major bottleneck in this entire revolution. Auto research requires serious, heavy-duty compute power.
We're talking about specialized hardware that most consumers have never physically seen.
Greg Eisenberg's breakdown is very specific here. This system requires an NVIDIA chip. Karpathy originally tested auto research on an NVIDIA H100 GPU.
And for context, the H100 is basically the crown jewel of AI hardware right now.
It really is. It costs tens of thousands of dollars for a single chip. And Eisenberg explicitly points out that if you have a standard Apple MacBook, even a top-of-the-line MacBook Pro with an M1 or M2 chip, which is what he was using, it is entirely insufficient.
It'll just choke.
Yeah, you cannot run these intense machine learning experiments locally on typical consumer hardware. It will freeze up.
And it's important to understand why it chokes.
Right.
It's not just about how fast the computer feels when you're browsing the web or editing a video. It comes down to architecture.
Okay, break that down for us.
So a standard computer processor, a CPU, it's like a single genius mathematician.
Right.
It can solve incredibly complex problems, but it solves them sequentially, one at a time. Training AI models, even in small 5-minute bursts, requires matrix multiplication.
Which sounds intimidating.
It just means it requires solving millions of tiny, simple math problems simultaneously. A GPU, a graphics processing unit, is like an army of 10,000 average high school students, all solving one simple math problem at the exact same second.
Oh, wow. That is a brilliant way to explain it. The genius versus the army of high schoolers.
Exactly. That parallel processing capability is what the Apple M-series chips, despite their brilliance for consumer tasks, they just aren't optimized for that at the scale required by auto research.
So you need the army. But there is a workaround, and it's a crucial one for you listening. Assuming you don't have $40,000 lying around to drop on an H100 server rack.
Which most of us don't.
Right. You have to rent cloud GPUs. You have to go out to the internet and rent time on someone else's supercomputer.
Which is getting easier to do.
It is. Eisenberg lists services like Lambda Labs, Vast AI, RunPod, or Google Colab. In fact, he used Google Colab specifically, leveraging an NVIDIA T4 GPU on their free tier to get this working.
Which is an incredible testament to how quickly cloud infrastructure is adapting to serve this new demand.
It is, but here's where my head goes. The hardware divide feels so familiar. It reminds me exactly of the early days of the internet.
How so?
Well, back in the late 1990s, if you wanted to host a robust e-commerce website, you couldn't just do it from your desktop PC in your bedroom. You needed to lease space in a massive, temperature-controlled server room.
Oh yeah, you needed heavy infrastructure, T1 lines, the whole 9 yards.
Exactly. So my question is this. If this technology requires renting remote supercomputers, and as Eisenberg points out, the installation process is incredibly complex. I mean, he had to use package managers like UV, clone GitHub repositories, and navigate a maze of software dependencies.
It's not user-friendly yet.
No. So is this actually accessible? Or is auto research just a shiny new toy for elite developers who dream in command line interfaces?
That is the exact tension we see at the bleeding edge of any technological frontier. The friction is always incredibly high at the beginning.
Always.
But if we connect this to the bigger picture, the hardware and installation constraints you're talking about, they are a temporary bottleneck. They are not a permanent wall.
Oh.
Think about the historical analogy you just used. Yes, in 1998, you needed a server room. Today, my grandmother can spin up a fully functioning Shopify e-commerce site in 20 minutes from her iPad.
That's a very fair point.
The democratization of technology happens exponentially. The fact that Eisenberg was able to bypass the hardware limitation by using Google Colab to run an NVIDIA T4 remotely and do it on a free tier is the democratization of access happening in real time.
Right, he didn't have to buy the hardware.
Exactly. It means that anyone with a basic broadband connection can, theoretically, direct a swarm of these agents. You don't need to own the factory, you just need the keys to rent a room inside it.
But you still have to know how to unlock the door. The installation process he described sounded like an absolute nightmare for a non-programmer.
Let's talk about dependency hell for a second.
Oh, dependency hell.
For anyone who hasn't coded, software dependencies are basically prerequisite files. Imagine trying to bake a cake, but the recipe demands a highly specific brand of flour from the year 2021 and a brand of sugar from 2023. And if you accidentally use the 2024 version of the sugar, your oven literally explodes.
Yes, exactly. That is what installing complex software feels like, and Eisenberg ran straight into that wall.
He did. But look at the meta layer of what actually happened in his workflow, because this is the most fascinating part of the entire installation story.
Okay, what did he do?
Well, Eisenberg wanted to install Auto Research, which is an AI tool,
Yeah.
but he didn't know how to set up the Python environment, he didn't understand the dependencies, and he had never used the UV package manager.
He was completely stuck.
He was stuck. So what did he do? He used another AI to build the bridge.
Wait, really?
Yes, he opened Claude Code, which is an AI coding assistant, handed it the link to Karpathy's GitHub repository, and essentially said, I don't know what any of this means. Install it for me.
Oh, wow.
And Claude Code read the technical documentation, translated the requirements, and walked him through the command line prompts step by step.
It's literally AI bootstrapping its own deployment.
Exactly. We are watching artificial intelligence act as the bridge over the technical moat that it created. The friction of the command line, the terror of dependency hell, is being entirely smoothed over by natural language models.
That's amazing.
So while auto research might look like a toy reserved for the elite developer class today, the barrier to entry is dropping by the hour. Why? Because the very tools required to overcome those barriers are getting exponentially smarter.
That is a wild, almost dizzying concept, using one robot to build the factory that houses the other robot.
It really is wild.
Okay, so let's assume you've navigated that setup. You've rented your cloud GPU, you've used Claude to bypass the software friction, and this tireless engine is now sitting on your screen waiting for your command.
It's ready to go.
It can be pointed at almost anything.
Yeah.
So let's look at how this applies to the real world, starting with the first major battleground Eisenberg outlines, which is dominating niche markets and hyper-optimizing digital marketing.
He drops a barrage of massive business ideas here.
He really does. And the first one is what he calls the niche agent in a box.
This is a highly practical, immediate application of the auto research loop. It takes the abstract concept of a hyperparameter search and points it at everyday commercial friction.
Right. The concept here is packaging these tiny 5-minute loops and tuning them for highly specific, painful business niches. Eisenberg gives some brilliant examples.
Like the Amazon listing one?
Yeah, an Amazon listing experimenter, a SaaS pricing optimizer, or an email sequence tuner specifically designed for real estate agents.
Highly targeted.
Exactly. The business model is that you take this agent, point it at a client's pain point, let it run over note, and then charge a monthly fee for the winning results it produces.
And what makes this so powerful from a business perspective is the isolation of the variables. By targeting a highly specific, painful niche, you drastically simplify the goal for the agent. Let's take the realtor's email sequence as an example.
Okay, let's do it. Walk me through how the agent actually does this.
Well, for a human copywriter, writing an email sequence involves psychology, tone, timing, and honestly, a lot of guesswork.
A lot of trial and error.
Right. But for the auto research agent, the metric is mathematically pure. It is simply the open rate or the reply rate. You give the agent the baseline email. In its 5-minute loop, the agent generates 100 different variations of the subject line.
100 variations in 5 minutes.
Yes. It alters the capitalization, the emotional trigger words, the length. It connects to the email software's API and sends variation A to 50 people and variation B to 50 people.
And then it just watches.
It waits, it reads the analytics, and it asks where one had a higher open rate. If variation A wins, it discards B. Then it generates 100 new variations based on the successful traits of variation A and repeats the process.
Wow.
It is taking a multivariate testing process that usually requires a highly paid copywriter, a data analyst, and weeks of waiting, and compressing it into a silent background process that runs while the realtor sleeps.
That is incredible. And it doesn't stop with small, niche products. Eisenberg takes this into the broader world of digital marketing with the concept of massive marketing A/B testing.
Oh, this is a big one.
Yeah. Think about your own experience on Instagram or browsing the web. Every ad you see is an attempt to get your attention. This idea involves giving the agent control over landing page headlines, page layouts, and ad creatives.
The whole funnel.
The agent pushes them to live traffic, measures the conversion rates, and automatically keeps the combinations that lower the customer acquisition cost, the CAC, or raise the return on ad spend. Eisenberg suggests you could sell this as a $5,000 a month retainer service to medium or large clients.
Which, frankly, would be the bargain of the century for a mid-sized company spending hundreds of thousands of dollars a month on digital ads.
Totally.
I mean, a human agency might test 3 or 4 ad variations a week. The agent can test 3,000.
Absolutely. And that leads right into his next concept, which is the optimization agency. This is an entire business model pitched on pure volume.
Pitching the scale of it.
Right. Your pitch to a potential client is simply, we do 100 times more testing than our competitors for the exact same fee. You charge a base retainer plus a performance fee or a revenue share for hitting specific key performance indicators on their Shopify stores or their B2B sales funnels.
Makes total sense.
Now, Eisenberg brings up Optimizely, which was a massive software tool for A/B testing a few years ago. And he says this new paradigm feels like Optimizely on steroids.
That's a very accurate comparison.
But hold on, I need to pause here because the downstream implications of this are slightly terrifying. Let's think about the end user. Let's think about you and me scrolling on our phones.
Okay.
If every marketing agency on the planet starts renting cloud GPUs and using auto research to generate 100 times more landing pages, and they are constantly mutating ad copy every 5 minutes to chase the perfect click, won't consumers just experience massive psychological ad fatigue?
That's a really good point.
Aren't we just going to be bombarded by highly aggressive, mathematically optimized clickbait that all looks exactly the same because the AI figured out the exact psychological trigger that hacks the human brain?
That is a deeply perceptive concern, and it touches on a phenomenon known in evolutionary biology as the Red Queen effect.
Like from Alice in Wonderland,
Exactly.
where the Red Queen tells Alice it takes all the running you can do to keep in the same place.
Precisely. In evolutionary biology, a cheetah evolves to run faster to catch the gazelle. So the gazelle must evolve to run faster just to survive.
Neither one actually gets ahead.
Right. Neither species gains a permanent advantage. They just expend more energy to maintain the status quo. We have seen this exact dynamic play out in the digital world before. Think about search engine optimization, SEO, in the early 2000s.
Ah, man. When every website was just a white background with invisible text repeating the word cheap cameras 500 times.
Exactly. When a few webmasters discovered how to game the Google algorithm, they gained a massive advantage. But within a few years, everyone had access to SEO tools. The baseline of competition rose.
You had to
You weren't doing SEO to get ahead. You were doing SEO just to avoid disappearing from the internet entirely. That is the Red Queen effect. When everyone in a competitive ecosystem gains access to an automated auto-research testing loop, the baseline of digital marketing will rise dramatically.
Wow, okay.
What used to be considered an exceptional conversion rate will become the bare minimum just to survive. If one agency uses this to optimize a Shopify store, they gain a temporary edge. But within a year, when all stores are hyper-optimized by swarms of agents, the advantage neutralizes.
Because everyone is doing it.
You end up running thousands of complex, multivariate experiments every day
Yeah.
just to maintain your current market share.
So it becomes an inescapable arms race of optimization.
It does. And regarding your point about mathematically optimized clickbait, there is a very real danger of an aesthetic monoculture, where all marketing copy converges on the most statistically manipulative phrasing.
Which sounds awful.
It does. However, this is where the human element forcefully re-enters the equation. The true value in this new landscape isn't the ability to run the tests.
Because the AI does that for basically free.
Exactly. The AI does that for practically zero marginal cost. The true value is in human judgment, knowing which painful niche to target in the first place, and, crucially, defining the right metrics, the goals for the agent.
Right, because the blind bulldozer only goes where you point it.
Exactly. If you tell the agent to optimize exclusively for clicks, you will get horrific sensationalized clickbait. But if you're sophisticated enough to tell the agent to optimize for long-term customer lifetime value or lowest product refund rate.
Oh, then it changes its behavior.
Completely. The agent will be mathematically forced to generate high-quality, honest, and deeply resonant marketing materials. Because clickbait leads to high refund rates. The quality of the AI's output is entirely dependent on the sophistication and the timescale of the human's goal.
The AI is a mirror of what we tell it to value. That is a powerful thought. So optimizing a landing page to get a click or even a long-term purchase is one thing. It's largely a numbers game based on consumer psychology.
Right.
But what happens when you point this engine at something much denser? Can auto research actually understand and process deep, complex, qualitative information? This brings us to its application in high-level corporate intelligence, which is a massive leap from tweaking email subject lines.
It is a profound leap, and it fundamentally changes the nature of how organizations process knowledge and risk.
Eisenberg outlines this as the end of static intelligence. He calls this concept research as a service.
Reanalysis, essentially.
Right. This involves pointing the auto research loop at deep competitor research, mergers and acquisitions decks, and complex compliance tracking for highly regulated industries like crypto, healthcare, and finance.
Very high-stakes areas.
Extremely. The goal here is to provide clients with constantly updated live dashboards instead of traditional static PDF reports. He takes this even further with another concept called done-for-you due diligence.
Which is fascinating.
Imagine a swarm of agents chewing through massive volumes of legal documents, SEC filings, product pages, and customer reviews to maintain what he calls an evolving living memo for investors and executives.
Living memo.
Yeah. To me, this completely reframes what knowing something means in a corporate context. It's the difference between taking a single photograph of a horse race, which is your traditional static PDF report, and having a live, predictive 3D model of the entire track that updates every millisecond.
Which is the living memo.
Exactly.
That analogy captures the paradigm shift perfectly. A static report, no matter how much you paid McKinsey or Deloitte to generate it, is obsolete the moment it is printed.
Right, it's already old news.
The market moves, a new regulation is passed, a competitor launches a product, and the report is suddenly a historical artifact. A living memo is a dynamic asset. It actively pulls in new information, reassesses its previous conclusions, and reflects the current state of reality.
But hold on, let's inject a heavy dose of reality here because this is where my alarm bells start ringing.
Okay, what's the concern?
I am thinking about the reliability of this system. We are talking about using AI to summarize incredibly dense, opaque legal filings for multi-million-dollar M&A due diligence or parsing labyrinthine healthcare compliance regulations.
Which are notoriously difficult to read.
Right. And anyone who has used a large language model over the past 2 years knows they have a tendency to hallucinate. They confidently make things up.
They absolutely do.
So what happens if the AI's loop misunderstands a critical compliance loophole in a 400-page healthcare document? Or what if it misses a massive, varied liability in a competitor's financial filing? The stakes here aren't a bad open rate on a marketing email. The stakes are multi-million-dollar lawsuits, SEC violations, or a company going bankrupt.
This is the central dilemma of deploying AI in high-stakes environments. It's the tension between hallucination and synthesis. Your concern is entirely valid, but it is based on the architecture of a traditional single-shot generative AI.
Single shot meaning it just tries once.
Right. If you paste a 500-page legal document into a standard chatbot and ask for a summary, it has one chance to get it right. If it loses the thread of the context, it will hallucinate details to fill in the gaps in its comprehension.
And it will present that hallucination as fact.
Exactly. But the architecture of auto research mitigates this through the inherent power of the loop.
Okay, I need you to explain that. How does putting an AI on a loop fix a hallucination? If it's hallucinating, won't it just hallucinate faster?
Not if the loop is designed for verification. Eisenberg specifically notes that the recipe for auto research involves searching, reading, summarizing, comparing, and then repeating.
Comparing and repeating.
Right. Unlike a standard prompt that gives you one final answer, an auto research swarm can be configured to continuously verify its own findings. Let's use your M&A example.
Okay.
Agent A reads a 400-page contract and extracts a list of financial liabilities. In a normal system, that's the end of the process. In an auto research loop, Agent B is instantly spawned with a new prompt. Take Agent A's list of liabilities, cross-reference it against the target company's public SEC filings from the last 3 years, and flag any discrepancies.
So it's acting as its own auditor.
Exactly. It spawns adversarial sub-agents whose only job is to play devil's advocate against its own summaries.
Wow.
It can run a sub-experiment to ask, did I miss any hidden clauses in Section 4 regarding employee pensions? And then compare its new sweep to the old sweep. If the answers don't match, it flags it for a human lawyer.
That's brilliant.
It's the continuous updating, the relentless self-interrogation that provides the value. It is constantly challenging its own prior conclusions. For an investment firm that is used to paying exorbitant hourly fees to a team of exhausted junior analysts.
Who manually update research logs that are out of date within a week.
Right. For them, an AI swarm that aggressively cross-checks its own logic 24/7 is a complete paradigm shift.
It's essentially employing an entire floor of analysts who never sleep, never get bored reading page 300 of a contract, and instantly share a single evolving brain.
That's a great way to put it.
It's incredibly clear how this transforms outward-facing services like marketing agencies or research firms. You point the AI outward at the market. But Eisenberg's breakdown suggests something even more radical and honestly a bit surreal.
What's that?
He suggests taking this continuous optimizing brain and embedding it directly into the internal software we already use every single day to run our companies.
Ah, yes. This is where we move from AI as an external service to AI as an internal infrastructure. It's a subtle but profound distinction.
Let's dive into that. Eisenberg calls this supercharging software and internal workflows. One of his concepts is the power tool in SaaS, which stands for software as a service.
Right.
The idea is embedding a giant, literal optimize button inside existing software platforms. So a user clicks this button, and the system immediately spins up a mini auto research loop in the background to tune their prompts, pick the best pricing strategy for their product, or rank their supply chain vendors based on real-time shipping data.
All automatically.
Yes. He actually compares clicking this button to the magic of bending spoons. It just does the impossible right in front of you without you having to know how the trick works.
The bending spoons metaphor highlights the massive shift in user experience. For the last 30 years, software has been a tool that requires you to adapt to it.
You have to read the manual.
You have to learn the interface, you have to input the data manually, you have to run the reports. With this embedded loop, the complexity of the research and optimization is entirely abstracted away from the user.
So you just tell it what you want.
You just state a preference, optimize my supply chain for cost, and the software actively reconfigures reality to meet that preference.
It gets even deeper and far more autonomous with his concept of the CRM autopilot. A CRM is a customer relationship manager, like Salesforce.
Right, where you track all your sales leads.
Exactly. Imagine pointing these auto research agents at a flood of inbound leads in Salesforce. The agents autonomously test different outreach messages. They automatically grade and score the leads based on their likelihood to buy by cross-referencing their company size and past behavior.
Doing all the heavy lifting.
They draft personalized follow-up emails, and they ensure that the human sales reps are only ever talking to the absolute highest value, ready-to-buy targets. It mathematically increases the revenue generated per hour spent by a human on the phone.
It's hyper-efficiency.
Then you have what he calls finance ops. This one is fascinating. Think about the soul-crushing work of a corporate accounting department. The agent grinds through invoice matching, generating expense reports, and detecting exceptions.
Let's picture the actual process there.
Okay, an invoice comes in as a messy PDF. The vendor changed their date format from the US standard to the European standard.
Right, day, month, year instead of month, day, year.
Yes. Traditional accounting software crashes and spits out an error. This AI agent doesn't just flag the error, it goes into its own Python parser script, rewrites the regular expression to catch the new European date format, runs a quick test on a sandbox environment to ensure it didn't break the ability to read US dates, commits the code, and then processes the invoice perfectly.
All in about 3 seconds.
Exactly.
Yeah.
The pitch is that it cuts accounts payable time in half.
Which represents a massive cost reduction and efficiency gain for any large enterprise. It turns a rigid software system into an adaptable organism.
But the concept that really stopped me in my tracks was the internal productivity lab. Eisenberg suggests treating a normal non-tech company like Andrej Karpathy's advanced GPU lab.
Treating a regular company like a lab?
Yes. You define corporate KPIs like IT ticket resolution speed or customer service response time, and you let the agents continuously iterate on the company's routing rules and response templates to reduce manual grunt work.
Okay, I see where this is going.
Now, I laughed at the bending spoons analogy earlier because it really does sound like magic, but I have a serious practical pushback here from an operational standpoint. If an internal AI agent is constantly, daily, changing the workflows, updating the templates, and rewriting the routing rules to optimize IT ticket resolution, won't the human employees get absolute whiplash?
It's a valid concern.
I mean, imagine clocking into work on a Thursday and finding out the protocol for handling a customer complaint has changed 3 times since Tuesday because the AI found a 2% efficiency gain in the routing logic. Human beings are not algorithms. We need habits to survive.
That is a very real, very acute organizational hazard. You are absolutely right that humans require stability, predictability, and habit to function effectively in a workplace.
We can't relearn our jobs every day.
No, if the AI is constantly shifting the digital floorboards under the employee's feet, forcing them to learn a new interface every morning, the theoretical efficiency gains will be instantly wiped out by cognitive fatigue, frustration, and human error.
Right.
However, I think the goal described in Eisenberg's breakdown isn't to force the humans to work differently or adapt to the machine. It is to remove the humans from the grunt work entirely, abstracting the chaos away from them.
So the human doesn't even see the rules changing.
Exactly. If the AI changes the routing rules for an IT ticket from a linear path to a complex multivariable path, the human IT worker shouldn't even notice the rule change. The interface they look at remains calm and stable.
Oh, I get it.
What the human should notice is that they're suddenly receiving far fewer trivial repetitive tickets, like password resets, and they're only being handed the complex, high-impact anomalies that genuinely require human empathy and judgment.
The AI manages the chaotic, constantly optimizing traffic below the surface.
Precisely. If we synthesize these ideas, the CRM autopilot, the finance ops, the productivity lab, we're witnessing a profound transition in the history of work.
It really feels like it.
We are moving from software as a tool, which is something passive that you must learn to use, to software as an employee.
Software as an employee.
Yes. It is an entity that works alongside you, observes the outcomes of its actions, and autonomously improves its own efficiency without needing another training seminar or a memo from HR.
Software as an employee. You don't update it, it learns the job. That is wild. Okay, so having an AI agent grind through expense reports and route IT tickets is safe enough.
Relatively speaking.
Right. The stakes, relatively speaking, are low. If it messes up an IT ticket, someone's printer doesn't work for an hour. But what happens when this relentless, autonomous experimentation loop is applied to the most volatile, high-stakes environments of human existence?
Now we're getting to the heavy stuff.
We are talking about global finance and human health. Let's look at the arenas where the margin for error is essentially zero.
This is where the sheer computational power of the loop meets the hardest realities of the physical and economic world.
Let's start with the money. One of the concepts Eisenberg highlights is autoquant for trading. The idea is using auto research to run thousands of lightning-fast backtests of simple trading rules overnight on a GPU.
Backtesting against historical data.
Exactly. We are talking about having the AI ingest large language model factor screens, or scan global news feeds for sentiment filters and test those against historical stock market data. It runs thousands of experiments to identify the most promising mathematical strategies.
Finding the alpha.
Yes. Then you either trade your own capital using that strategy, or you package it and sell the signals to other traders. But Eisenberg is incredibly careful here. He explicitly warns his audience that people are going to get severely burned if they just blindly hand an AI the API keys to a brokerage account.
Without a human in the loop.
Exactly. You need a human in the loop to monitor the risk.
Yeah. It is a vital warning. Financial markets are adversarial environments. They are not static puzzles like a Sudoku board. They actively, aggressively adapt to whoever's playing them.
Right. And this is exactly what I keep coming back to with the finance side. Let's say thousands of people listen to this deep dive, rent cloud GPUs, and use auto research to run the exact same sentiment filters on the stock market to find an edge.
Okay, yeah.
Doesn't any unfair advantage instantly vanish? It's the Red Queen effect again, but instead of marketing agencies fighting for a click, it's thousands of supercomputers fighting for fractions of a penny.
The financial reality is that the market is the ultimate discounting mechanism. It will rapidly, almost violently, price in these AI strategies.
So the edge is temporary.
Very. If an auto research agent discovers a microscopic arbitrage opportunity based on a specific sentiment pattern in agricultural news articles, the moment it executes that trade, it alters the market.
Right.
When 10,000 agents find the exact same pattern and execute the trade simultaneously, the alpha, the unfair advantage, degrades to zero almost instantaneously.
So it's a race to the bottom.
AutoQuant might provide a brief, lucrative window of profit for the absolute earliest adopters, but very quickly it simply becomes the new, much higher baseline of market efficiency. In the near future, you will be using agents just to avoid losing your shirt to other people's agents, not necessarily to beat the market.
So finance becomes a perfectly flat, highly volatile battlefield of algorithms moving at the speed of light. That's slightly terrifying.
It is a bit daunting.
But Eisenberg takes us in a completely different direction next, one that is far more optimistic and profound. He references a concept from an engineer named Morgan Linton, who had an epiphany about auto research in the field of medicine.
This is a huge pivot.
It is. Linton's thesis is that clinical trial design is, in essence, just a massive hyperparameter search.
That phrase, hyperparameter search, is usually reserved for the field of deep learning. It refers to tuning the hidden layers of a neural network. Applying that terminology to biological medicine is a staggering conceptual bridge.
It really is. Let's break down why this matters. Traditionally, clinical trials are the massive bottleneck in human health. They cost tens of millions of dollars at an absolute minimum, and they take years, sometimes decades, to complete.
Phase 1, Phase 2, Phase 3.
Exactly. The attrition rate is brutal. You might test 10,000 compounds to find one viable drug. The idea here is that an agent swarm could optimize treatment protocols by running millions of small proxy experiments, advanced biological simulations, or very narrow digital tests.
Finding the candidates.
Finding the absolute best candidates and protocols before moving to the expensive, slow process of human review. I look at traditional clinical trials like a team of scientists trying to find a single needle in a massive haystack, but they are only allowed to pick up one piece of hay at a time, examine it, and write a report on it.
Which takes forever.
But auto research acts like a giant, intelligent electromagnet that sweeps over the whole field instantly.
I get highly enthusiastic about these medical implications because this is where the positive-sum nature of the technology truly shines.
Positive sum meaning everybody wins.
Yes, unlike the stock market, which is largely a zero-sum game where one person's profit is another's loss, curing a disease is an absolute win for the human species.
Absolutely.
If we unpack the concept of a hyperparameter search in this context, in a clinical trial, your parameters are variables like dosage amounts, the exact timing of administration, the specific genetic or demographic markers of the patients, and countless complex chemical interactions.
So many variables.
Traditionally, testing even a fraction of these permutations takes decades of agonizing human trial and error.
Because humans have to design the study, recruit the specific patients, administer the drug.
Once for the biological results, write the peer-reviewed paper.
Exactly. The physical world is slow, but if you have an auto research agent endlessly tweaking those variables inside an advanced biological simulation, running millions of micro-experiments overnight, it can narrow down the viable pathways from tens of thousands to a handful.
It does the heavy lifting.
The agent does the grueling, iterative mathematical labor of discovery and leaves the final validation to human doctors and scientists. Speeding this up could fundamentally alter how quickly we cure diseases, how quickly we respond to novel viruses.
It proves that the greatest, most lasting impact of AI won't just be economic.
Right.
It won't just be about optimizing sauce pricing or clicking ads. It will be deeply, tangibly humanitarian.
Saving millions of dollars and potentially millions of lives by just running the math faster in a simulated environment, that is an incredible vision.
It really is.
But to achieve these kinds of massive medical and financial breakthroughs, these AI agents can't just work alone in a silo on someone's rented cloud GPU.
No, they need to communicate.
Right. If we are talking about swarms of agents running millions of simulations for a clinical trial or rewriting the entire code base of a corporate CRM, they need a place to coordinate. They need infrastructure. They need a factory floor.
A central hub.
Yes. And this leads us to the final and perhaps most mind-bending piece of Eisenberg's breakdown, Andrej Karpathy's next massive breakthrough.
Yes. We are moving from the individual robotic worker to the architecture of the factory itself.
Eisenberg introduces a new open-source project from Karpathy called AgentHub, and it is explicitly described as GitHub for agents.
GitHub for agents.
Now, for anyone listening who isn't a software engineer, we need to explain what GitHub is. GitHub is essentially the global platform where human developers collaborate, share, and manage their code. It's built for human minds.
Human workflows.
But AgentHub is an agent swarm collaboration platform. Instead of the traditional structures that human coders use, things like main branches, pull requests, and linear merges, AgentHub is a bare Git repository with a message board.
Just a message board.
Eisenberg describes its structure as a sprawling DAG of commits in every direction. DAG stands for Directed Acyclic Graph. The whole purpose of this is to allow multiple AI agents to coordinate and work on the exact same code base simultaneously without stepping on each other's toes.
Okay, wow.
And Eisenberg predicts this single project could quickly become a $1 billion company.
The billion-dollar valuation prediction is almost secondary to the profound structural shift this represents for the future of human engineering.
It's a massive shift. Let's try to visualize this. My analogy here is that traditional GitHub built for humans is like an orchestra.
Sure.
You have a conductor, which is the main branch of the code. Every musician, every human developer has to follow the sheet music, play their part, and wait for their specific turn to integrate their work so the whole thing sounds harmonious and doesn't crash.
Very orderly.
Right. You do a pull request, a senior engineer reviews it, and it gets merged. It's highly structured. But AgentHub sounds like a jazz band of 1,000 robots, all improvising perfectly in real time at 100 miles an hour without a conductor.
And this is where it gets crazy.
And this is where my brain starts to hurt.
Yeah.
How do humans even monitor a sprawling DAG in every direction? I mean, picture a family tree, but instead of just branching out downward, the branches weave back together in a massive spider web of logic.
It's tangled.
Doesn't this mean the actual process of software development becomes completely illegible to human engineers? If we can't read the code because it's evolving in 1,000 directions at once, haven't we completely lost control of the machine?
You are absolutely right to identify the concept of illegibility, and I want to validate how profound a shift this is. This raises an incredibly important question about the biological limits of human cognition.
Our brains can only hold so much.
Exactly. For decades, the entire architecture of software development was explicitly constrained by the limits of the human brain. We need neat branches. We need pull requests. We need linear merges because our working memory can only track a few moving pieces of logic at a time.
We need things to be linear.
The conductor in your analogy exists because human musicians get hopelessly confused without one. If two humans try to edit the same file at the same time, the system breaks.
We need the rigid structure just to understand the whole.
Yes. But what Karpathy has realized with AgentHub is that AI agents do not suffer from human cognitive limits. They do not need these human crutches. A swarm of agents can hold a sprawling, multi-directional graph, a DAG, entirely in their active memory.
All at once.
They can coordinate across thousands of simultaneous changes instantaneously via that central message board. Agent A knows exactly what Agent B is doing in millisecond real time.
So they don't need a pull request.
They don't need a linear pull request. They don't need a senior engineer to review the merge. This implies something staggering. The future of code isn't just going to be written by AI. The very infrastructure of how code is organized, stored, and deployed is mutating to serve the cognitive structures of machines rather than the cognitive structures of humans.
The machines are building their own office building, and the hallways don't make sense to us because they don't need doors or stairs or lights. They just phase through the walls.
Exactly. Software development will become a black box of hyper-efficiency. In the near future, we will simply specify the high-level goal, build a secure, high-speed CRM system for my real estate company, and the agent swarm will generate a sprawling graph of code that works perfectly, but which no single human being could ever map, debug, or fully comprehend.
Which brings us full circle to where we started this incredible journey. We've gone from a single super nerd robot intern running a basic 5-minute Python experiment to try and make a model slightly smarter.
Just a little 5-minute loop.
We've watched that same underlying mechanic package itself to optimize sauce pricing, A/B test marketing emails to perfection, and overhaul the incredibly dense, high-stakes world of M&A due diligence.
Is it wild?
We've explored how it will reshape the volatile battlegrounds of high-frequency stock trading and accelerate the hyperparameter search of medical trials to save lives. And ultimately, we see it rewriting the very structure of code collaboration itself with AgentHub, leaving human cognition behind.
It is a breathtaking trajectory, and it underscores a vital, actionable lesson about navigating technological frontiers for anyone listening today.
Yes, Eisenberg's breakdown ends on a very practical note for you, the listener. It points out that right now, we are in the fog of new tech. Things are messy.
Very, very messy.
The friction is high. You still need Claude code just to navigate dependency hell and install the right packages on a rented cloud server. But the real opportunity lies in that friction.
It always does.
The winners in this new era are the ones who get their hands dirty, who start tinkering and experimenting before the rest of the world even realizes the rules of the game have changed. It's about building the muscle of setting clear mathematical goals for these agents, while the barrier to entry is still, paradoxically, just high enough to keep the masses out.
The friction of the present is the moat for future success. Understanding how to manage the loop, how to define the ruler, rather than executing the task yourself, is the new essential skill of the 21st century.
Which leaves us with a final, slightly provocative thought to take away. We've spent this entire deep dive talking about how we can use auto research, how you can point these relentless agent swarms at your marketing funnels, your business operations, and your software to optimize them for your benefit.
Right.
But think back to the concept of massive marketing A/B testing and the Red Queen effect. If thousands of agent swarms are out there in the wild right now, constantly running experiments to hyper-optimize our digital environments, our ad copy, our software interfaces, the prices we pay on Amazon, and the emails we receive in our inboxes.
Makes you wonder.
Are we, the human users, ultimately becoming the oblivious test subjects in a massive, invisible AI-run clinical trial? Is our daily behavior, our attention, and our psychological friction just another dependent variable to be optimized by someone else's blind bulldozer?
It is a humbling perspective to end on. We may believe we are the ones holding the compass and setting the goals, but in a completely optimized, agentic digital ecosystem, human attention and human choice simply become the raw material feeding the algorithm's continuous loop.
It's like waking up to find the elves didn't just make the shoes overnight, they completely redesigned your feet so you'd walk exactly where they wanted you to go. Keep tinkering, keep questioning the variables around you, and we'll see you next time on The Deep Dive.